All right, let's look at the beginning of our stats section of the ACM course, looking at statistical information. Unit 4.1, crunching the numbers. A population consists of all subjects under the study. So here we're talking about conducting some sort of survey or study. A sample is a subset of the population. For example, if you wanted to do a survey of 1,000 registered voters in Harris County about their opinions on garbage pickup, the population would be every registered voter in Harris County. That is the population. If we wanted to conduct this survey of 1,000 registered voters in Harris County about their opinions on garbage pickup, the population that we could pull those 1,000 people from is every registered voter in Harris County. And the sample would be the voters selected for the survey. And of course, I'll upload this file in the video folder that accompanies this lesson. So the sample are the 1,000 voters that we select for the survey. The population is every registered voter. So how do we pull these samples? There are 4 different kinds of samples. There are several techniques that can be used to conduct surveys. The 4 that this text mentions in this course are the random sample, the systemic sample, a stratified sample, and a cluster sample. So let's talk about each. A random sample means that every subject of the population has an equal chance of being selected. The key there is that to be random, it will be an equal chance that everyone in the population can be selected. Like jury duty, I think. They just randomly select people from the population. A systemic sample is where you pick every nth, meaning whatever number. So pick every nth member of the population. This is like quality control in a warehouse or something. They'll pick every 10th item and make sure that it's not defective or something. So pick every nth member of the population, every 10th phone from a phone factory, something like that. A stratified sample is where the sample is broken into groups. Such as age, or people selected from groups. And we'll look at examples of all of these in just a second. And then finally, a cluster sample, in which an existing group of the subject that represents the population is used for the sample. So these are groups that already exist, and you pull from that for your sample. So now we'll look at the next part. Identify the type of sampling used for the following. A survey of property owners about a tax increase by having a computer randomly draw the addresses of 100 people. The idea that it's a computer randomly drawing, of course, means that it's a random sample. The computer will choose randomly, so everyone has an equal chance of being selected. Turn the page. A survey of disease of corn in farms in Prince George's County by checking on 20 ears of corn from 200 farms that grow corn. So again, the definition we wrote for a stratified sample is that the sample is broken into groups, and that can mean people selected from groups. So this represents a stratified sample. Because we are going to take 20 ears of corn from each of the 200 farms that grow corn. So these people are selected into groups. They are broken into groups. The groups being these 200 farmers that grow corn. So again, think about it as broken into groups here, like the farms. Next, we have a company that uses checking every 20th widget produced for defects. So, widget is just like an item. So any item here. So again, a company that checks every 20th item for defects, that is our systemic. Anytime we're checking for defects, that's usually describing, something like in a factory where you do quality control. That is systemic. And finally, a group of researchers are studying the results of test scores in high schools in North Carolina. They randomly pick 15 school districts. Then they would pick 5 high schools in each district to look at their scores. So the one we haven't used is a cluster sample. And again, a cluster sample we defined as an existing group of the subject that represents the population is used for the sample. So they want to identify the test scores of high schools in North Carolina. Well, we have school districts in North Carolina. They randomly pick 15 of those. And then they pick 5 high schools in each district. So this is an existing group that represents the population. So we think about that as a cluster sample. I know it's kind of confusing, maybe the difference between stratified and cluster. So let me know if you have any questions there. So what do we do with this data once we have it? The data that is collected for a statistical study is called raw data. So just pulling in the data without organizing it. That is the raw data. 2 ways that can be helpful to organize the data are frequency distribution and stem and leaf plot. So let's take a look. Categorical frequency distribution. This is a table where you list different categories. And then count up how many individuals in a sample or population fall into each category, usually by using tick marks. You know, like the tally marks, 1, 2, 3, 4, and then a diagonal line for 5. You then list those frequencies, and we'll do this example below. A teacher makes the following list of the grades that she gave her 25 students on an essay. Build a frequency table that includes relative frequency and cumulative frequency. The relative frequency is found by frequency in the category divided by total frequency. So these are the grades that we see here. Raw data. This is not organized. We're going to organize the data ourselves. So how many students had A's? I'm just going to cross them out as I go. Cross that one out, make a tally mark. Look for another A. There's an A, make a tally mark. There's an A, make a tally mark. There's an A, make a tally mark. So how many tally marks did we make? 4. So a frequency is just how many times this event occurs. How many times did I record A's for this one essay? I recorded 4 A's. Again, the total, it tells us that there were 25 students. So the relative frequency is 4 out of 25. Now, cumulative means that you add as you go. I'll just put that there. Add as you go. The definition for cumulative frequency is that you add each frequency to the sum of its predecessors as you go. So this is our first entry in the cumulative frequency column, it's just 4. Now, how many students had B's? As you cross it out, put a tally mark. I'm crossing out 2. I put 2 tally marks. Here's 2 more. I make 2 tally marks, so there's 4 and there's 5. And then 2 on the bottom, 2 tally marks. Again, 1, 2, 3, 4, and the diagonal 5. So 5 plus 2 makes 7. So 7 out of 25 students. That's our relative frequency. The number of students who made a B, 7, out of the total, 25. And then here we do the preceding number of 4 plus 7. I mean, we could just write the number 11 here, but I want you to see where it comes from. 4 plus 7. How many students made C's? It looks like this is the highest or the most frequently occurring grade. So let's do 1, 2, 3 C's to start with. Here's a pair. So there's my 4th tally mark, and there's my diagonal 5. Here's 1, 2, 3 C's. And then 1 on the bottom. Of course, it wouldn't hurt to double check, use a highlighter, whatever you want to do. But here I count 9 C's, meaning that the relative frequency is that 9 out of 25 students made a C. And here's how the cumulative frequency column works. I take my 11 from the previous, add to it this 9 that we just found. So now our running total is up to 20. How many students made a D? Only a few. There's 1, 2, 3 D's. So 3 students made a D. That's 3 out of 25. And now again, we take our previous total for the cumulative frequency, add the 3 that we just found, and that makes 23. Finally, only, I think, 2 students made an F. There's 1 and there's the other. So a frequency of 2, we put our 2 tally marks. Frequency of 2. There's nothing else left here. So that means 2 out of 25 students made an F. So we have 23 plus 2, which is 25. And that is the number that we needed to see, because this is out of 25 students. Our tally marks should also equal 25. 5 and 5 makes 10, however you want to add this in your head. But 4 plus 2 plus 4, that also makes 10. So we're at 20 plus 3 plus 2. We have 25 tally marks. Also, the relative frequency needs to add up to 1. Relative frequency should add up to 1. And if I added 4 out of 25 plus 7 out of 25 plus 9 out of 25 plus 3 out of 25 plus 2 out of 25. When I just add the numerators, we would have 4 plus 7 plus 9 plus 3 plus 2. That comes out to 25. So, of course, our denominators would stay the same. 25 out of 25 is indeed 1. So let's turn the page. So I kind of answered some of this, but which grade had the highest frequency? Well, it's the highest number we see under frequency, and that's 9. So C. Students who made a C had the highest frequency. And what is its relative frequency, meaning the part A? For a C, the relative frequency was 9 out of 25. Which grades had the lowest frequency? Well, which grade or grades, that's what that means, in case there's a tie. But there's not, so which grade had the lowest frequency? And that's F. 1 fewer than D. And part D, I just talked about. What number should the relative frequency add up to? Because it's out of 25 for each grade. All 25 students received a grade. And 25 out of 25 is 1. It should look like that. In this case, it was 25, so 25 out of 25. If it were 20 students, then 20 out of 20 would be the relative frequency sum. Finally, we will look at stem and leaf plots. A stem and leaf plot. This is a special table where each data value is split into a stem, the first digit, or digits, and a leaf, usually the last digit. It is used similarly to a histogram to compare data. In a simple stem and leaf plot with two digits, the first digit is the stem, the second number is the leaf. For example, in the number 32, 3 is the stem, 2 is the leaf. And so we make a vertical line like this. And we'll put our stems on the left, our leaves on the right. So create a stem and leaf plot for these numbers. So what about the number 7? What if it's only one digit? Well, then the stem is a 0. And then we do want to go from least to greatest here. So what are our one-digit numbers? 7, 3, and 8. So we have 3, 7, and 8. Now we look at our numbers from 10 to 19, our numbers that start with a 1. So we couldn't leave the stem blank here, so we put a 0 for the first row. But where are the numbers that start with a 1? I have 14, 16, 18, and 19. So we have 1, 4, 1, 6. So again, first digit 1, and then we have the second digit being a 4. The next entry, second digit being a 6. We have 1, 8, and 1, 9. So that represents 14, 16, 18, and 19. How about numbers in the 20s? 23, 27, 28. I think that's it. Nope, there's one, 26. So our stem is the first digit, a 2. And then looking at my numbers in the 20s, I have 23, 7, 8, and 6. So we're going to list that 3 first, and then the 6, and then the 7, comma, and the 8. So what if the values repeat? Numbers that start with a 3, I have 35 and another 35. And that's it for the 3s. So you list them both, 5, comma, 5. If the values repeat, we need to list that. Numbers that start with a 4, make a little mark above. There's the 41 and the 42. So we start with a 4 for the stem. There's our leaf for the 41. And here's our leaf for the 42. So what else do we have? The only thing left is this 68 that we haven't touched. So can we jump straight from 4 to 6 in our stem and leaf plot? No, we cannot. So there's a blank entry for the leaves of 5. There are no numbers in the 50s. But now we have our stem for 6, and this is our only number in the 60s, a 68. So part of using a stem and leaf is to make a key. We have to make a key, and the key can be any entry. It looks like this. 2 lines separating it, 6 equals 26. It doesn't matter what number you use to show this concept. If you want to do 3/5 equals 35, this is just a way to that we show what this information means. You can do 6 line 8 equals 68. It's just a key, like a map key that shows you what the information means. If the number is a 3-digit number, such as 145, then the stem is 14 and 5 is the leaf. The leaf is the last number. And there always has to be a key, well, here it is, so the reader knows what the stem and leaves represent. So let's make another stem and leaf on the back here. I believe this group is supposed to represent the ages of poet laureates or something. So we look at our ages. Oh, and this is in order for us. This is nice. So we start with a stem of 3 and a leaf of 2. And that's this piece right here. Perhaps you're wondering, why didn't we put a 2, a 1, and a 0 above that and leave the leaves blank? We're not going to have a poet laureate, in their child years. So we only need to start our stem and leaf where the information starts. Our first age for this stem and leaf plot is a 32. So that's where we start the stem and leaf. What we have to do is account for any numbers in between our entries. So if there was no one in their 50s, we would have to do 5 and then a blank leaf. But so here we go. Next we have a 4, and then these ages right here. A stem of 4 with a leaf of 4, that's our 44. A stem of 4 with a leaf of 5, and a stem of 4 with a leaf of 6. And now these are in our stem and leaf plot. What about the ages of people in their 50s? 51 is a stem of 5, a leaf of 1. Here's our 54. Here's our 55, our 57, 58, and 59. So it's just a way of organizing all of these ages. Poets in their 60s, so there's a stem of 6, a leaf of 0. There's our stem of 6, now a leaf of 3, and then a leaf of 4. And then finally our poets in their 70s. A stem of 7 with a leaf of 0, and then a leaf of 5, and then a leaf of 9. And so that readers can figure out what we mean by this stem and leaf, we make a key and just pick any number. If you want to say 5 line 4 means 54, that's fine. You can use 3 with a line and 2 is 32. There's no wrong answer for the key unless you pick a number that doesn't exist in your stem and leaf plot. So that's it for section 4-1. Hope that helps. Let me know if you have any questions.